Hello and welcome to another video in this series looking at how to achieve structural steel design using AI and retrieval augmented generation. In this video I have tasked the latest Claude AI Fable 5 to solve all 168 of the structural steel design examples in the AISC 36022, companion to the AISC Steel Construction Manual, Volume 1, Design Examples, version 16. Fable 5 was publicly released on the 9th of June 2026. The methodology used is consistent with my previous videos using Claude Opus 4.7. I use the Claude desktop app, with a simple prompt requesting the solution of all questions in the dataset, and directing that the RAG vector database of AISC 36020 to be used to collect the necessary sections and equations for grounding with the specification. Fable 5 spent just under 2 hours working 100% autonomously through all 168 questions. The results are highlighted on my webpage, which I will discuss here, and the page link is below in the description. The solutions were compared to the verified solutions database and were considered with respect to key numerical design values, the outcomes of structural adequacy checks, and the member or connection sizes selected. Each design was then marked as matching the solution, a different but safe design, or an unsafe design. An unsafe design is when the member or connection selected is different to the solution and is non-conservative. Designs that were safe but were not matching is when some numerical values differed, while the member or connection selected is either the same as the solution or more conservative. The designs that were matching the solution or were marked as different but safe were aggregated into the safe designs category. The key result for Fable 5 is a safe rate of 96%, including for the 168 designs, 148 matching designs, 14 designs with some differences but conservative, and 6 designs different and not safe. We can see from the comparison of the chapters, which cover a quite specific topic in each, the unsafe designs are not clustered within any particular topic. Aggregated further by question category, there is no particular clustering either. It is revealing to consider further the 6 unsafe designs. In A6.2, a W-shaped stability brace was specified that was one member size lighter than the verified solution. In A6.5, an L-shaped stability brace was specified that was 5 member sizes lighter than the verified solution. In C1A, the design moment was miscalculated to be nearly an order of magnitude smaller than the verified solution. In E14B, the compression capacity of an angle column was miscalculated to be nearly 2 times larger than the verified solution. In II-A19B, a W column was specified that was one member size lighter than the verified solution. In K10, a connection plate was specified that was one plate thickness lighter than the verified solution. So 6 of the 3 unsafe designs missed by only one size, and given the general conservatism of the steel specification, we wouldn't be overly concerned about those. So of the 168 designs, Fable 5 only badly missed 3 designs, 1.8%. Okay, following that, there is a question-by-question comparison you can read for yourself on the webpage. You can also scroll up here and you can download the question and solution dataset to do your own benchmarking. Note that AIs need access to a RAG vector database of the AISC 36022 specification in order to properly ground their calculations, rather than rely on their training data to remember the specification equations. See the RAG DBs page to create this RAG and connect to your AI on the website. So let's try and interpret these results in the context of a structural engineering group in an AEC firm. It might take an engineer 200 to 300 hours of calculations to complete the 168 designs, assuming each design took on average 1 to 2 hours to solve. This might represent about $7,000 to $10,000 of direct wages, or $20,000 to $30,000 of billable hours, for a junior engineer in the USA at $35 hour wages or $100 hour billable. Fable 5 completed the 168 questions in just under 2 hours. That's at least 100x faster than an engineer. The cost calculation is indirect since I used my subscription. However, Claude estimated the input and output tokens Fable 5 used, and I multiplied by the Fable 5 API rate $10 per million for input tokens and $50 per million for output tokens, and I estimated the cost as $115 plus or minus 25% for the token estimation. That's 180x to 260x cheaper than an engineer. So if your structural group was prepared to give AISC 360 steel designs to Fable 5, it could nominally produce 96% accuracy designs with a 100x increase in productivity and a 200x decrease in cost, compared to a junior engineer. Set up your free structural steel design RAG to use with any AI LLM model. Step 1. Download the free RAG vector databases from steelcoldform.com. Step 2. Follow the instructions on the engineering RAG page to set up the API for running queries. Step 3. Connect your LLM of choice to your RAG API, allowing your AI agent to query your RAG as required.